So hi, let's solve Cambridge IGCSE Chemistry Paper 2 Multiple Choice Extended October-November 2024 and Paper 21. So this is going to be an MCQ paper, and I always say that MCQ papers are like the great savers. Why? Because MCQ is something that either you can get right or you can get wrong. So if you are able to grasp all the concepts in a good way, then your MCQ paper should be a 40 on 40. Okay? So let's get started with this paper today. Which row describes the arrangement and motion of the particles in a liquid? Okay, firstly, we should know the arrangement. That is, obviously, I know that's random and particles are touching. So, random with space between all particles. Acha, the thing over here to understand is that if you try to visualize it, that in a liquid there is a space between all the particles, that is not possible because look, these are the particles. Some will have space between them, this is a liquid for instance, but some particles will have space between them, but some particles might not have space. Like over here, look, there's no space. So you have to keep this in mind that though that particles are random and they are touching, but there's with space not between all particles, so that's wrong. Are ordered lattice with all particles touching? There's no order or lattice. And ordered lattice with space, no, that's incorrect. So this one is correct, that random and particles are touching. Firstly, that they're random, and secondly, that they're touching. And there's space between some but not between all. Okay, which gas has the lowest rate of diffusion at room temperature and pressure? You should know that the lowest rate of diffusion is going to be of a gas that is the heaviest gas is going to have the lowest rate of diffusion. The more heavy you are, the slower your rate of diffusion. So a gas produced, okay, now we are given with some kind of hints and we have to guess the gas ourselves. A gas produced when ammonium chloride is heated with aqueous sodium hydroxide. You should know that ammonium chloride. What kind of substance is ammonium chloride? Ammonium chloride is a ammonium salt. And what kind of substance is sodium hydroxide? Sodium hydroxide is a alkali. And you should know this is in your syllabus, that when you have ammonium salts and you make them react with alkalis, what gas do you produce? You produce ammonia gas, salt and water. Okay. So over here, what kind of gas are we going to produce? Ammonia, which is NH3. Okay, a gas which makes up approximately 78% of clean dry air. This is going to be obviously nitrogen gas. Don't write N only, it's N2 because it's a nitrogen gas. The gas produced when sodium carbonate is added to dilute hydrochloric acid. Okay. Now, sodium carbonate added to dilute hydrochloric acid. What do you think? A carbonate and an acid. When you have a carbonate and you make it react with an acid, what do you produce? You produce carbon dioxide. So over here, what we're talking about CO2 gas. And lastly, the gas produced when zinc is added to dilute sulfuric acid. You have zinc is what? Zinc is a metal. And you have a metal and you have an acid. Metal plus acid produced which kind of gas? They produce H2 gas. So we're going to have hydrogen gas. Now we have to check which has the lowest rate of diffusion. It's going to be, the lowest rate of diffusion means it's going to be a gas that is going to be the heaviest. So which is heaviest? Ammonia has MR of, I guess, it should be 17. Nitrogen has 28. Carbon dioxide has 44 and hydrogen has 2. So it has to be carbon dioxide. Okay. Because it's heavy, so it will take more time to diffuse. Which diagram represents one helium atom? Okay, one helium atom, which diagram represents? It should have, let's see the periodic table, then you're going to have a better idea, okay? Because I believe that in questions like these, you should always have periodic table with you. Okay, this is helium. It has 2 protons and it has basically a nuclear number of 4. It means that it has 2 protons and 2 neutrons, and then you get an answer of 4. So how many protons does it has? 2, and neutrons as well 2. So let's visit our question again. Okay, so it should have 2 protons and 2 neutrons. So over here I can see these 2 protons. Okay, 2 protons correct, 2 protons correct, because protons cannot be in the shell. Then it should have 2 neutrons and 2 electrons. So option B is correct. Okay, the diagram shows part of an ionic lattice structure. Which compound does the diagram represent? Okay, firstly, it can be KBr, which is potassium bromide. Then it can be sodium oxide, which is Na2O. Then it can be magnesium chloride, which is MgCl2. And then it can be carbon monoxide. Okay, the first thing that we know over here for sure is going to be that it cannot be carbon monoxide. Why it can't be carbon monoxide? Because why it can't be carbon monoxide? Because carbon monoxide, as we know, that it is a simple molecular structure, and it cannot be a simple molecular structure because we are told it's a ionic lattice. And secondly, more than this ionic lattice term, we can see for ourselves positive and negative ions, so not this. Now all these three, they are ionic compounds, but there is something interesting that you guys have to notice. Please, I'd love you guys that before me, you guys answer this question. It's gonna be a really big thing if you are able to tell which one is the correct option. I believe your chemistry is A1. You know, you are a A-star student if you are able to tell. Okay, now I'm gonna tell the correct answer, then I'm gonna explain the reason. Correct answer is A, and the reason for that is, count the number of positive ions. 1 positive ion, 2 positive ion, 3, 4, 5 and 6. Now count the number of negative ions. 1, 2, 3, 4, 5, 6. This tells us that positive ions and negative ions in this square piece of lattice, the positive ions and negative ions, they are equal in number. Okay, positive and negative ions are equal in number. And over here we can see Na2O. That means N is, sodium is twice that of oxygen. Over here we see MgCl2. This tells us that Cl is twice that of magnesium. Only equal positive and negative ions are in KBr, potassium bromide. I hope you get it. Moving on to the next question, which says, which statement about nitrogen molecules and ethene molecules is correct? Nitrogen molecules, and then we have ethene molecules. Nitrogen is N2 and ethene is C2H4. And basically nitrogen is, you have two nitrogens, something like this, and between two nitrogens you are basically sharing how many? 1, 2 and 3 pairs of electrons. So there's a triple covalent bond, and the remaining electrons, they're gonna be 1 2 3 4 1 2 3 4 5 6 7 8 7 and 8. So that was what you had to do. Okay, a nitrogen molecule has 2 more shared electrons than an ethene. Let's draw ethene as well. So ethene is gonna be something like C2. So you have 2 carbons, something like this, and then H4. So 1H, 2H, 3H and 4H. So 1 here, 1 here, 1 2 3 4, 1 here and 1 here. So we are done with this. Okay, so a nitrogen molecule has 2 more shared electrons than an ethene molecule. No, a nitrogen does not have 2 more. That's incorrect. An ethene molecule has 3 more shared electrons. Okay, in nitrogen, how many shared electrons we have? We have 6. 1 2 3 4 5 6. In ethene we have 1 2 3 4 5 6 7 8 9 10 11 12. In ethene we have 12. So there are 6 more in ethene. A nitrogen molecule has 4 more. No, an ethene molecule has 6 more shared electrons than a nitrogen molecule. That's correct. Why that's correct? Because we just figured out that nitrogen is 6, whereas in ethene you're sharing 12 electrons. So the correct answer for this one's gonna be AD. I hope you get this. Okay. Sulfur is a simple molecule with the formula S8. Which row? It's a simple molecule. This word that it is a simple molecule simply tells us that it's going to have a simple molecular structure. So it's going to have a low melting point, and there's going to be force of attraction between the sulfur atoms or between the sulfur molecules. It's going to be molecules because it's a simple molecular substance, and in a simple molecular substance the force of attraction is between the molecules, not between atoms, because an S8 sulfur looks something like this: 1 2 3 4 5, 6, 7 and 8. This is one sulfur, you can say, kind of molecule or whatever. This is one S8. Okay, so this is one S8, and there are many S8s similar to this. There's gonna be one more S8 like this. So between the sulfur, I don't know exactly, but this is one S8 and this is another S8 molecule. Between these two S8 molecules, there is a weak intermolecular force of attraction. You call it weak intermolecular force of attraction. Okay, between the atoms there is a covalent bond. Over here there is a covalent bond. Between the atoms you have a covalent bond. Here, these are all covalent bonds and they're very strong. But between two sulfur molecules you have weak force. Okay, so that is what you need to understand, that you're going to have weak force of attraction between the sulfur molecules. Okay, which identifies a property and an explanation of the property for both diamond and silicon IV oxide. Okay, property is that they are very hard and they have a high melting point. Good lubricant, poor conductor. Let's see, high melting point, both of them have. Both have giant covalent structure with many strong bonds between the atoms. That's correct, because in a giant covalent structure the bonds are between the atoms. Why? Because in diamond and graphite, this is one carbon attached to 4 more carbons like this. So over here the carbon atoms. Okay, so this is basically your carbon atom. Over here one carbon atom is attached to other carbon atoms by strong covalent bonds. These lines, they represents the covalent bond. Okay, so one carbon joined to other carbon by covalent bond. In giant structures this is the case, so B is going to be correct. Poor conductor, both contain only, no, that's incorrect. For poor conductor it should be that there are no mobile electrons. That's the reason they are poor conductors. Okay, which statement about the structure of metals explain why metals are malleable? Because layers of the metal lines can slide over each other. I guess I just spoke out this line, so it's going to be option number B. What is the formula of iron 3 oxide? Simple, Fe 3+. Why 3+? Because it's a 3 over here and O2 negative. This 3+ comes here, this O2 negative comes here, so it is Fe2O3. I hope you know this, that this 2 above oxygen comes down here below iron, and this 3 above iron comes down here below oxygen. So it's going to be option number D. Okay, calcium carbonate is heated, calcium oxide and carbon dioxide gases are formed. The equation is shown here. 225 kg of calcium carbonate is heated until there is no further change in mass. The yield of calcium oxide is 85 kilograms. What is the percentage yield? Okay, so now this is the mass of calcium carbonate that is heated until there is no further change. So this is the mass of calcium carbonate that you are heating. So how much mass? If you heat 1 mole of this, you're going to produce how much of calcium oxide? 1 mole. Okay, so if you basically heat, let's calculate out the mass of 1 mole. 1 mole mass is going to be, this is 40 because we know calcium is 40, and this carbon is going to be 12 plus 16 will be 3 times. Why 3 times? Because we have 3 oxygens. So basically it's going to be 40 plus 12 plus 16 plus 16 plus 16, which makes it 100. So 100 of calcium carbonate should produce how much of calcium oxide? 12 plus 16. 1 mole should produce 1 mole, na? So it should be 12 plus 16. So 12, no, not 12. It should be 40 plus 16. Why 40? Because this is calcium, not carbon. So it should be 40 plus 16, which makes it 56. So if we have 100 grams of calcium carbonate, how many grams of calcium oxide are we going to form? We're going to form 56 grams of calcium oxide. And now since we have 225 grams, 225, how much should we produce? We're going to produce X grams. So it's 225 times 56 upon 100, which will give me the value of X. So 225 times 56 divided by 100. So I should have 126 grams of calcium oxide. 126 grams of calcium oxide I should have theoretically, but unfortunately this is not what I have. What I have is 85 kilogram. I should have 126 kilogram, not gram, kilogram, because when you take one thing in kilogram, you convert all other things to kilogram. Okay, so I should have 126 kilogram, but I have 85. So what is going to be my percentage yield? It's going to be 85, which is what I have, upon 126, which was what should I have, because when I performed it in laboratory I got 85, but in reality this is what the theoretical mass is coming out to be. When in theory, when I calculated it out, that 1 mole gives me 1 mole mass of this gives me 56, so 225 should give me this. I got this as my answer, but they told me that I got this in laboratory. This means in laboratory there must be some impurity or something that decreased the mass. So now I'm calculating what is the percentage yield times 100. So 85 upon 126 times 100. 85 divided by 126 times 100, 67.4%, which is option C. Why? Because when you round it off, 67.46%. So when you round this 4 becomes 5. Okay. Next question says that the apparatus for electrolysis is shown. This is the apparatus. These are the electrode. This is electrolyte. Which statement is correct? Copper forms at the anode in some electrolysis. No, copper is a positive ion. Anode is also positive. Copper should form at the cathode. Hydrogen forms at the cathode. In some that's correct. Hydrogen has to form on the cathode. Oxygen at the cathode, sodium at the anode. Incorrect. Okay, which statement about electrolysis of aqueous copper 2 sulfate is correct? Okay, when copper electrodes are used, the solution turns from blue to colorless. No, when copper electrodes are used, basically the solution does not change color. Why no color change? Because the amount of copper that is lost from the solution, the same amount of copper returns back into the solution as well. So incorrect. When graphite electrodes are used, bubbles of gas are formed at the cathode. At the cathode, bubbles of gas don't. Basically, what's going to happen is that bubbles of gas are not going to form in case of copper, but when you're using graphite at the cathode, what are you going to form? You're going to form copper. Okay? So you're not forming hydrogen. So no bubbles of gas. Again, you're forming copper because copper is less reactive than hydrogen. In the reactivity series, you know na, sodium, calcium, and then reactivity series continue. Then there's hydrogen and then there's copper. So hydrogen is above copper. And since copper is below, the more below you are in the reactivity series, the more chances you have of getting discharged. The more you get discharged. So copper is going to get discharged and no bubbles are going to be seen. When copper electrodes are used, the anode gets smaller. Yeah, the anode has to get smaller. Why? Because basically the copper from the anode is basically what's happening is that it's mixing in the solution. I really like coloring and I'm sorry for this. Okay. Which statement describes an advantage of using hydrogen oxygen fuel cell in a car compared to a gasoline engine? Okay, hydrogen oxygen fuel cell advantage. The hydrogen is difficult to store, so that's a disadvantage. Hydrogen is flammable, disadvantage. The hydrogen is used is made from hydrocarbon, disadvantage. The only chemical product is water, and that's a advantage. Two reaction pathway diagrams are shown. Which arrow represents the activation energy for the reaction which releases thermal energy? Since it's releasing thermal energy, that means it has to be a exothermic reaction, and for the exothermic reaction, the reaction pathway should be that the these are the reactants, so reactant should be above and the product should be below. So the activation energy is gonna be this A. Okay, why A? Because it's always from the reactants to the P. This pathway is for endothermic reactions, and if it was endothermic, then the activation energy would be C, but this is not the correct answer since it's A. Okay, which statement about the Haber process is correct? A high temperature is used to because the reaction is slow at room temperature. That's correct. Because the more temperature, the faster the rate. A high pressure is used because there are more moles of gaseous reactant than the moles of gaseous product. A high pressure is used because there are more moles of gaseous reactants. Uh, that does not make sense, but let's see. A nickel catalyst? No, not nickel. You use iron catalyst. So, an iron catalyst is used to increase the equilibrium yield of ammonia. That's incorrect. Why? Because catalyst cannot increase the yield. A catalyst can only increase the rate. So, it has to be 1 and 2. So, it has to be option number A. Which substance is a raw material used in the manufacture of sulfuric acid? It has to be, it's a raw material. This is not a raw material. This one right here is a catalyst, and you don't consider your catalyst as your raw material. So it has to be sulfur dioxide, because when you have sulfur dioxide, you make it react with oxygen and then you produce sulfur trioxide. Okay. Which colors are seen when litmus and methyl orange are added to separate samples? Okay, you have litmus and then you have your methyl orange, and they're added to separate samples of aqueous sodium hydroxide. Litmus is going to be blue and methyl orange is going to be orange or yellow. Okay, so what basically happens is that it turns yellow for a very small period of time. It's basically orange. So it's option number A. It turns yellow exactly at the midpoint, exactly at 7 pH. Your methyl orange is gonna turn yellow, and as the pH increases 7.1, it turns exactly into orange. So it's but for a very short period of time that sometimes you are unable to notice as well. Information about the solubility in water of 4 oxide is shown. Okay, which oxide when added to water gives a solution with the pH less than 7? Less than 7 means that it has to be a acidic solution. So nitrogen dioxide. Yeah, that's correct. Why? Why not silicon? Because it's insoluble. So when it's added in water, it does not give a solution because the ions don't basically dissolve. Okay. Copper sulfate is made when copper carbonate reacts with dilute sulfuric acid. Okay, pure copper sulfate crystals are obtained. Which reagent is in excess and how are crystals obtained? Obviously, you add your basically the base is in excess. Okay, the base is copper carbonate over here. So this one is going to be in excess. And what are we going to do to obtain crystals? We're going to first filter, then we're going to evaporate the solution to the crystallization point, and then we're going to cool it. So it makes option B the correct one. Which statement about elements in group 1 and group 7 of the periodic table are correct? Okay, group 1 and group 7. Bromine reacts with potassium chloride. No. How can bromine react with potassium chloride? Chlorine is more reactive than bromine, so it cannot react. Okay, iodine is mono. Nahi. Lithium has a higher melting point than potassium. As you go down, the melting point decrease. So that's correct, because look, lithium, sodium and potassium. So as you go down, the melting points decrease. So lithium obviously is going to have more melting point, because as you are gradually going down, your melting point is also going down. Okay, some information about elements. Group 7 of the periodic table is shown. Okay, we are melting. This is obviously bromine. This is so easy. Why? Because look, this substance is a liquid at room temperature, and only bromine is a liquid at room temperature. Why? Because room temperature, for instance, it's 20 or 30, whatever the room temperature is. So do you see that -7, it's the melting point, it's going to turn into a liquid, and at 59 it's going to be a gas. So between -7 and between -7 and 59, it is a liquid. So at room temperature, no matter what temperature is it, room temperature obviously cannot be 59. So bromine is always a gas. Okay, manganese oxide, MnO2, is a solid, is a black solid. The equation for the reaction between manganese oxide and dilute hydrochloric acid is shown. This is the equation. The reaction produces a pale pink solution. Okay, which property of transition element does the reaction show? Because it produces a pale pink solution, firstly, so the property can be it form colored compounds. Okay, because that's what we can see. Nextly, it can act as catalyst. Basically, over here, I don't think it's acting as catalyst. Basically, it's not acting as catalyst. It can have variable oxidation numbers. Why not high melting points? Because over here, by just looking at the reaction, we cannot tell about the oxidation numbers. Obviously, one sorry, it's gonna be 2 and 3. Why a variable oxidation number? Over here manganese has of 4 plus, and over here manganese have of 2 plus. How do I know? Simply just look. Oxygen is 2 negative and I have 4 oxygen, so I have a total charge of 4 negative. To balance out a 4 negative, I need a plus 4. And over here I have 2 chlorines. One chlorine has negative 1 and 2 chlorines are going to have a 2 negative charge. To balance out a 2 negative charge, I need a 2 plus charge. So it's gonna be 2 and 4. 2 and 4, which makes option D. Okay, part of a steel strip is protected from rusting using sacrificial protection. That means that sacrificial protection simply means that you use a more reactive metal to protect the lesser reactive one. Which is suitable sacrificial metal? It should be more reactive, so it should be zinc. Why not potassium? Potassium is also more reactive, but potassium is extremely reactive. Okay, it's so reactive that what's going to happen is that if you make potassium on the ship, it's going to blow up. Okay, it's going to just blow up reacting with water. It's that much reactive, so you can't have extreme reactivity. You need something that's more reactive than iron, because steel is basically iron, but at least not that much reactive that it's going to be used up in like just 5-10 minutes. All potassium is going to be used up. Zinc at least is going to protect it, but it's going to stay there for some time. Okay, which row is gives a use of the name metal and the two properties which both explain the use? Aluminum, aircraft conduction, yeah. High density, yeah, that's incorrect. It should be low density. Okay, copper, electrical wiring, yeah. Good electrical conductivity, and ductile, that's extremely correct. Why ductile? Ductile basically means that it can be drawn into wires. Why it means this? Because if they are not ductile, how can you make wires out of copper? So to make wires, you need something that's ductile. Basically, if you have, for instance, I say you have sulfur. You cannot make your wires out of sulfur because sulfur is not ductile. What's going to happen is it's going to be brittle and crumbly. It's going to be powdery. Okay. Okay, next is that you have an apparatus that is used for the extraction of aluminum by electrolysis. Which equation represents the reaction at the anode? I believe that should be a child's play for you guys, that you're going to have at the anode. What kind of ions you're going to have? Not aluminum. You're going to have an oxide ion that's going to basically lose the electrons and turn into oxygen. That's what's happening. Okay, which gas is both an element and present in clean dry air? Is an element. This one is an element. This one is also an element, but it is not present in clean dry air. Chlorine is a toxic gas. If you inhale chlorine, you're gonna die. Okay, oxides of nitrogen formed in car engine are removed using catalytic converter. What happens to the oxides of nitrogen in the catalytic converter? So basically oxides of nitrogen, they are converted to nitrogen. So you have NO. So what's going to happen is that you're going to convert it into N2 plus O2. So there's a 2 over here. So what is happening is that this oxygen is being lost. Look, you have oxygen over here with nitrogen, but this oxygen is being lost. Over here, nitrogen has no oxygen. So nitrogen is losing oxygen. So loss of oxidation, oxygen is reduction. So what happens to oxides of nitrogen? They got reduced. Why they got reduced? Because they lost their oxygen. Okay, what is the equation for photosynthesis? I believe this is a child's play. They're going to have carbon dioxide, then you're going to have water, but over here the balancing is incorrect, so it's going to be option number A. Okay, 4 statements about members of the same homologous series are listed. They have the same volatility. No, they have, as you go down the series, the volatility increases. They becomes more the volatility decreases. Sorry, I was thinking about viscosity. It's not viscosity, it's volatility. The volatility decreases because the more the chain lengths, for example C4H8 and C8H16, this is going to be more volatile. Why? Because it has less carbons. As the carbon increase, the volatility also increase. Okay, they have the same molecular formula. No, they have the same functional group. Yeah, they have the same functional group and the general formula, so it's going to be 3 and 4. Okay, ethene reacts with steam to produce ethanol. Which row describes each compound? Ethene, because it has ene means a carbon-carbon double bond, so it's going to be saturated or unsaturated? It's going to be unsaturated. Why? Because when there's a double bond, this shows, what does a double bond shows? Unsaturation. And ethanol is going to be saturated because ethanol does not has a carbon-carbon double bond. Ethene is C2, and you have 4, let me draw this hydrogen here, that's going to be more easy. And ethanol is this is your ethanol structure. Okay, so there is no carbon-carbon double bond over here, but over here this double bond basically means it's unsaturated. Okay, which process is used to make alkene from a long chain alkene? That's cracking. That's a child's play. Which fraction obtained from petroleum has the lowest boiling point? Obviously it's going to be the smallest fraction, naphtha or kerosene. Basically what we're going to do is that we are going to go to igcse syllabus. So igcse syllabus, chemistry, and I'm going to show you something over there that it's going to be, so this is your Cambridge igcse syllabus, and over here you are going to see all your fractions that, so these are your fractions and you should know them, that firstly there's refinery gas, gasoline, naphtha, kerosene. So naphtha is a smaller fraction, okay, than kerosene, because as you're going down A, B, C, D, the chain length of carbon is increasing. So what's going to happen is that the lower boiling point is going to be of naphtha because it's below kerosene. Okay, alkanes undergo substitution reaction with chlorine in the presence of UV light. Which equation shows a reaction this time? Not this, not this. So either HCl, this has to be formed, and alkane, so C3H8, this is an alkane, and C3H6 is an alkene. So an alkene cannot undergo substitution like this. So it's going to be option C. Information about 2 reactions of ethene is listed. Reaction 1 requires a nickel catalyst. So that's going to be addition of hydrogen because that's hydrogenation. Requires acid catalyst, that's going to be steam, because you know that when we make an alkene react with steam and add acid catalyst, what happens? What kind of substance are we forming? We're forming from an alkene we form an alcohol, and over here what we form? Basically what we form hydrogen. We add hydrogen into an alkene and we form an alkane. Okay, you should understand this. Which process converts this thing to this thing? So over here we have a OH and over here we have COH. So basically this is what we have, an alcohol, and over here this is what we have, an acid. So we're converting an alcohol into an acid, so we have to oxidize it. So CH3, this is ethanol and this is ethanoic acid, so we have to oxidize it. Bacterial oxidation, that's going to be correct. Fermentation, no. Fermentation, catalytic addition, no. We do oxidation. We add oxygen into it and basically it converts into a acid. The structure of ester is shown. Okay, this is the ester, and which identifies the number of esters and the 2 compounds from which it is made, which identifies the name of the ester. Okay, what is this part showing us about this ester? This part is showing us the alcohol that is used. Why is this part showing me the alcohol? Because over here I have this O, so this is the alcohol, and this part is showing me the acid that was used. I know that a 2-carbon alcohol has to be ethanol. Okay, a 2 carbon alcohol has to be an ethanol, and a 3 carbon acid, it has to be ethanoic or propanoic. I'm just testing you guys. It has to be propanoic acid. So the name of the ester is ethyl propanoate. Ethyl propanoate. So it has to be ethyl propanoate, and the compound 1, it's ethanol, and compound 2 is ethanoic acid. But what is compound 1 and 2 in it? I don't get it. But still, they could simply write alcohol and they could write acid over here. Okay, which statement about monomers or polymers are correct? Monomers are always joined together by addition. No, they're sometimes joined together by condensation as well. A polymer can be formed from a single type of monomer. Yes, if both sides have the functional group, or if there is a carbon-carbon double bond, then you only use one type of monomer. A polymer can be formed by joining two different types of monomer. Yeah, either you can use the same type or different types as well. What is always produced? Never. In addition reactions, you don't form water. So it has to be option number C. Okay, the diagram shows the structure of a naturally occurring polymer Q. I think by this time that it should be a child's play that this is protein. I don't even need to explain you guys this thing, because look, on one side you have nitrogen, one side you have carbon. Look at the pattern. Then again you have nitrogen, carbon. Then again nitrogen, carbon. Don't you look at the pattern that what's happening over here is NC, NC, NC. So NC, NC pattern is a protein, and all these are amino acids. Okay, which row shows the boiling point and the melting point of water change when a soluble impurity? So basically, impurity increases your boiling point and decreases your melting point. Okay, X is a white powder. The following tests are done on X. Now we have some kind of qualitative analysis questions, so you have to learn the table for this. Any one of you think that learning the salt tests, the tests for anions and cations and gases and everything, that's not important? Look, you have the last question in the MCQs from the table of the anions and cations, and you're not given with the table, so learn it. Okay, when a few drops of aqueous sodium hydroxide are added to solution of X, no precipitate. Okay, no precipitate, so it can be ammonia or potassium. Let's see. Okay, when X is heated with aqueous sodium hydroxide, no gases form. It means that it cannot be ammonium. It has to be potassium. Okay, X gives a lilac color when put into flame. Pakka potassium. Okay, when acidified aqueous silver nitrate is added to X, a yellow precipitate is seen. A yellow precipitate is always given in case of iodine, not bromine. In case of bromine, what kind of precipitate do you expect? Cream. So with that, we come to an end of our paper, and I hope you like this video. So thanks for watching, and bye bye.